For attending today's.
This meeting is being recorded.
Okay, yeah. For reference, we are recording this for. It's more like a podcast-like session, and we'd like to record for those who couldn't attend today. And so let's get started one more time. So thank you for attending today's TAICHI CSCW chat session. We are pleased to invite 3 distinguished researchers and entrepreneurs to be our speakers today to share their research and practical experiences of working on human AI collaboration topics. And Yi-Chieh and I will host this chat session. I'm Ying-Yu Chen. I'm an assistant professor at National Yang-Ming Giao Tong University in the Department of Communication and Technology. Yi-Chieh?
Okay. My name is Yi-Chieh Lee. I'm a research fellow in the NTT Japan, and I'm physically in Japan like 2 days ago. From 2 days ago, so I'm in Japan now. And I'm going to move to the US from the July, and so I will be an assistant professor in the US. Okay, so you can.
Yeah, for reference, I'm in Taiwan. And today's event will be about an hour and a half, 90 minutes, and we will open the discussion to all audiences in the last 20 minutes. Before that, please remember to mute your microphone, but you can feel free to leave your thoughts and questions in the Zoom chat. And so if you would like to leave questions in the Zoom chat, we can ask the question for you if you're too shy to ask. Yeah.
Okay, so now please allow me to introduce our speakers briefly. Dr. Michelle Zhou is the co-founder and the CEO of Juji.io. Her company dedicates to developing cognitive AI assistant and allowing no-coding background users to build up an excellent AI chatbot. Michelle, do you like to say hi to the audience?
Hi, everyone. Good morning. Good morning, good afternoon, good evening.
And good evening, yes.
Cool.
Okay, and next, Professor Hideaki Kuzuoka is a full professor at the University of Tokyo, and he is a paper chair of the CSCW 2022. He is one of the pioneers who introduced robots and gadgets to CSCW research. Hideaki, do you like to say hi to the audience?
Taiwan, everyone. Hello, I'm Hideaki Kuzuoka at the University of Tokyo.
Hi. Okay. So Dr. Dakuo Wang is a research staff member at IBM Research. He is also an adjunct professor at the Northeastern University. His recent works explore and develop human-centered AI system and facilitate humans AI collaboration. So Dakuo, do you like to say hi to the audience?
Hello, Dakuo Wang is here. I'm now based in Boston. Hi, everyone.
Okay, yeah. So again, thank you for joining this event today. And let's start today's conversations. We would like to welcome our speakers to introduce their work first. So Michelle, could you start to introduce your work? Yeah.
Ichi, may I share like just a couple of slides? Is it okay?
Yeah, sure, definitely.
Okay. So I think I see the sharing the screen. I'm going to just share it.
Yeah.
You should be able to see my screen right now, right?
Yes.
Great. Okay. So I have thank you first of all, Yi-Chieh, and also your co-organizers, Hao-Chuan, to actually invite us for organizing as well as for organizing this event. So I know this topic and today's topic is about human machine and human AI collaboration. So what I'm going to say a little bit about my current work, especially for the past probably 4 and 5 years. What do we call it? Elevating human machine relationship. And basically we now define the human machine relationship as the supervisor assistant relationship, because it's enabled by no code reusable AI. So I will say just a few words about it. So what do we do at the Juji is for the past 5 years now, we have been building a platform to enable what we call it accessible cognitive AI assistants. And for many of you who have heard of no AI and might be asking, so what is cognitive AI? So basically, it's still AI assistants. You can still, the AI assistant can still interact with people, communicate with people, but cognitive AI assistants also have what we call it advanced human soft skills, such as active listening, reading between the lines. So in particular, we have been focusing on 3 aspects of this platform. First, we wanted to enable at scale human interactions, especially empathetic and productive conversations between the AI and, the Microsoft updates. And so that's our first kind of aspect we've been working on. The second aspect is we want our AI assistants to read between the lines. So as if the users are chatting or communicating with a psychologist, so you can actually infer automatically about each user's unique characteristics. So we also call them to automatically derive conversational insights into individuals, into groups. And the last part of it is, as Yi-Chieh talked about earlier, so we really want to enable no code customization and testing and evaluation of such AI assistants, because most of people who have no AI expertise, no programming skills, maybe you don't even have a data or computational resources to run such a complex and powerful AI system. So really want to enable no code and to achieve at least 100x of a time to value. So here is an example, just a very concrete example, how people, how organizations are using our AI assistants. So let's say in a workplace, you have something called AI career assistant. So this career assistant can interact with each employee and on a daily basis or periodically on a weekly basis to really understand each employee's thoughts, feelings, and career needs at the scale. Because during this conversation, and the AI career assistant can automatically infer those needs, unique characteristics of each employee. Because this inference, it actually delivers what we call it workforce insights for enterprises to act upon. For example, enterprise in this case may obtain a happiness meter to understand how each employee is feeling about their job, about their position, and also soft skills map. Because of the inference, the enterprises will be able to see what's missing and what kind of skills their employees have. So it's kind of this is what we call the insights. In this particular use case, it will be workforce insights and more. And so anybody, when I say anybody, it means the HR partner, the HR coordinator, or maybe a manager can set up such a AI career assistant with no coding. So that's what I just want to give you a quick concrete example. So then I wanted to just quickly talk about why we believe that no code reusable AI really elevated the human AI relationship. So before, when a person has to do coding to create AI, we consider this the operator machine relationship, because you have to write every single line, say what the AI should do and how the AI should do. And so basically that's one. But however, now it's like you having a intern, you're having a human assistant. The human just needs to tell the machines what to do instead of how to do. So actually here I'm making it more concrete. To tell the AI what to do, but not how. So for example, like the example I gave, this AI career assistant, just maybe ask the employees a question like, what's your biggest challenge? What's the biggest challenge you are facing right now? But it doesn't need to tell AI, what if the user doesn't answer the question? What if the user says doesn't know, right? So this is basically just tell them what to do, but not how, as if you teach a human assistant. And more, because AI always needs to be improved. AI is not perfect. So we want to also enable humans to teach and improve AI continuously without interrupting any ongoing conversations. So again, you see, this is also like the supervisor-assistant relationship. And you want to keep groom them, right? You want grooming them, and you want to developing their talents as well. So it's basically, this is a kind of a new type of relationship. And there's just some of ongoing work in order to push this forward. And training data is always very precious. And how can you automatically generate them? And then in this case, this is very interesting. So for example, if your supervisor actually sees something is going wrong with the assistant, can the supervisor actually change it during even a training process in place, right? So this is like, I can talk a little bit more. And the last part of it is, because now every supervisor may not be computer scientists, may not even have any background in AI. How can we unbox the no-code AI, which means to tell them what the AI knows, what AI doesn't know, and what's the AI actually behind the scenes? So this is one of the biggest challenges for us. How can we unbox the no-code AI so anyone, everyone can actually go there, create their own custom version of AI assistant? Okay, so I'm going to stop it here and let next person. Yeah.
Yeah, thank you, Michelle. So maybe next.
I'm going to stop here. Let me stop. Yeah, I'm stop share. I stop sharing and somebody can take it over.
Okay, yeah. Hideaki, could you present your work? Yeah.
Okay, so I'm going to share my screen. Okay, so I've been working on remote. The first research I engaged with was remote assistance on physical tasks. So, for example, helper assists workers remotely to how to do physical tasks like repairing machine or something like that. And in this research, I mainly focusing on how we could communicate intentions by intentions of a remote person. And especially, I focused on involvement, how we can communicate involvement or attention of a person, or how technology can support predicting. We call it projection, but that means enabling participants to predict the subsequent actions of participant. And the key resource to enable this communicating intention is social cues like hand gestures, gaze, head orientation, body orientation, and sometimes leaning forward and backward. Those social cues support, enable us to communicate the intention of people. And to do that, I've been working on telepresence robot and also autonomous robot. Telepresence robots are the robot that remote, for example, helper control the robot remotely to communicate with workers. And this one is the relatively small robot, and this one is kind of human-sized robot. And this one is also, again, a smaller robot. And I've been working on these robots and tried to figure out what kind of action of robots are useful to communicate intention. And I also worked on autonomous robot, and this one can show body orientation. And this one is a smart speaker, robotic smart speaker that can show gaze to show the robot's intention to users. And so with this research, although I haven't worked on AI very much, through this research, I kind of start to think how AI can control these robots very intelligently. And more recently, I've been working on virtual reality system to motivate people work in learning something or giving lectures like this. And for example, in this research, in this experiment, I compared the case that, in this experiment, in this scene, this learner is learning English in the virtual environment. And I compared the two conditions. One is this person learns English alone in this environment. And another condition is this learner can see other people learning in this environment. And although they couldn't communicate each other in this environment, just simply seeing other people in this environment motivates this learner to learn more in this environment. So maybe these other learners don't have to be a real human, but these can be AI or agent or something. And in this example, when giving a talk in this kind of situation, I can't see how the listeners is responding to my talk. And the idea of this research is to integrate the participants' reaction to one avatar like this. And through the action of this avatar, I can kind of just imagine how you are, if you are understanding my talk or if you are interested in my talk or something like that. So we're still working on this and trying to figure out how the system can control this avatar to represent the audience's reaction in an effective way. So maybe AI can be used for to generate the reaction of this avatar. So these are brief introduction of my research, and that's all.
Yeah. Thank you, Hideaki. So let's welcome Dakuo to introduce his work.
Okay, let me share my screen.
Okay.
You can see my screen, right?
Yes.
Yes. Hi, everyone. Thank you so much for coming. So my name is Dakuo. In this talk, my title is Designing Human-Centered AI Systems for Human-AI Collaboration. So I build human-centered AI system to make it work in the real world. But because I'm from IBM Research, and many of you may wonder if my research work actually works, how come the IBM Watson Health system failed miserably? Even though I'm not personally working in the IBM Watson Health department, but in my own research work, I do have observed some similar problems in another scenario. So this is an AI-based clinical decision support system deployed in rural China, which has great integration into the existing EHR system. It has great performance. It has all these expandable AI design features. But doctors really hate it, right? So they stopped using it after 6 months. So the question here, which is my fundamental research question, why some AI systems succeeded, but some others failed in the real world, even when some of them claim that they have the human-centered design. So if we look back to the history, my colleague Jonathan Gruden developed this very nice chart to depict the history of ups and downs of AI. He refers it as AI summers and AI winters. So in 2 cycles back, Medical Research Council in the UK had this wonderful idea of building an automated medical image diagnosis system, but failed miserably. Very similar to today's IBM Watson Health story. Healthcare is not the only domain where AI failed in the real world. In the previous AI summer, we had the famous or the infamous smart agent system, Office Clippy, hated by everyone. Now we have chatbots, and it only takes 1 year for the people's sentiment to shift from the year of chatbot in 2017, and then to why chatbots failed in 2018. For the younger audience, maybe this MS Clippy story is a little bit before your age. Right? But we should all still remember Microsoft TAI, which is quite a disaster, as it takes only 1 day to turn TAI from a friendly chatbot deployed on Twitter to a pro-Nazi, anti-social Twitter account. So the history indeed repeats itself. Now, if we come back to the AI for healthcare case, right? I think that this picture is actually communicates a very important message. Why wasn't health failed? So the AI system is designed to be like a human doctor, and that's the actual problem. So I also observed this issue in my own work. Human clinicians are actually asking us, are you trying to design AI to replace us, right? So that's totally wrong. If you give human that perception, that's already wrong. They believe, these human doctors, they believe the right direction to go is actually to design AI to be explainable, trustworthy, cooperative partners so that human and AI can collaborate in these clinical scenarios. So now I believe we have an answer, a potential answer to this question, right? The answer is human AI collaboration. So the design and the research of human-centered AI systems should have a goal to achieve the human AI collaboration paradigm where human and AI can work together to deliver better outcomes in the real world. We know human AI collaboration, this sounds great, but this vision is so hard to achieve, right? We often don't have it yet. Why, right? So let's look at how researchers approach human-centered AI research topic today. A group of researchers focus on building state-of-the-art machine learning models, or the model that can be explainable or less biased. Another group of researchers focus on studying human behaviors from which they can propose design guidelines for UI and new features for AI models. But the problem is these two groups of researchers barely talk to each other. Right? In order to build this AI system to fully deliver the human AI collaboration promise, I believe we need to close the loop. So my work actually closed the loop as I conduct user-centered design studies to explore human behavior, and then embed these domain knowledges into the new data set or the new tasks. I then build these state-of-art models for this new task, and then we can incorporate these new models as a human-centered AI system, and then the system serves as an interface for the human intelligence and the machine intelligence to work together. So in my recent years of work, I have primarily focused on AI for healthcare, AI for education, and AI for data science. So I don't think we have time to go through all these three case studies, but the research methods I'm illustrating in these three case studies are definitely generalizable if we are focusing on some other user scenarios. So I want to stop my quick presentation here and leave the space to the audience to have the communication introduction. So if you're interested, you can read our papers or come to CHI this year. We have 3 papers going to be presented at CHI next month. Thank you. Sharing.
Yeah, thank you for Dakuo's presentation. So
Oh, congratulations on the 3 CHI papers. That's thank you. This was so interesting. And so first, we'd like to ask all of you, start with a question that's directed to all of you. And you have already touched this a little bit, but we are really curious. So we'd like you to expand more. So the first question for all of the speakers, Michelle, Dakuo, and Hideaki, what roles should AI system and AI agents play in human AI collaboration for ethical, pragmatical, and other perspectives? Could you give us an example? That's our first question. Any of you can jump in if you'd like to.
Okay.
I was trying to volunteer Dakuo because his talk really actually said about it. Just repeat what you said.
Yes, so thank you, Michelle. Yeah, I think the panelists are being so humble to give me this opportunity. So I'll just throw out my idea, and then we can discuss and also hear comments and feedback from the other two experts. So my idea is that we want to build AI systems, not to illustrate that we have the state-of-art model, we have the state-of-art technology, but rather to make the AI system really work for people, really work together with people, right? To deliver benefits to people. So I think from that perspective, right? So that's why I'm arguing this human AI collaboration. But I want to emphasize that even though we saw chatbots, we saw robots, right? These are very typical AI systems, but there are also many other AI systems that do not have a embodied avatar or virtual representation. They are also AI systems, and they also fit into this human AI collaboration paradigm, right? We shouldn't think about the AI need to have a face. It may not need a face, but they need to be able to bring benefit and work together with human. That's my 2 cents. Thank you.
So just tagging on what Dakuo said, I'm a big fan of Lee Collider's work on the human-machine symbiosis. So if you look at this work back in 1960s, he already said about it, right? So it's basically AI machines will serve as kind of assistant, assisting humans in their work. So of course, it's a collaborative. I also like very much Dakuo said earlier in his presentation, which I should say too. AI, it's not meant to replace humans. I am a firm believer of that. And it's really about augmenting humans. So we were talking about human augmentation and to enable humans to do more. I just want to give you one example, which I would consider is a very successful usage example of our work. So actually it's in Yi-Chieh's alma mater, UIUC. So they have an online program in the Geese College of Business, School of Business. They have only about 4 to 5 recruitment specialists. So recruitment specialists absolutely are not computer scientists. They know how to use PowerPoints, Excel spreadsheets. They don't know how to coding. They don't know AI. They don't even know, they don't care probably what AI it is. But they have a very concrete problem. They have many people, many prospect students, existing students go there, ask questions. So 4 or 5 people must answer about 40, maybe 50,000 questions. So just unattainable for them, right? So they spend the majority of the time, they could use that time to do something else. Not mentioning most of the questions are very repetitive. People ask, do you have a scholarship? I want financial aid, right? And where should I pay? What's the payment method looks like? So then they used our AI, again, no code, completely set up by themselves, maintained by themselves. So then we also told them, it's not about to replace you. It's really about to augment your work, right? So they are extremely happy because right now they teach AI once. The AI can repeat that kind of a learning, right? Answering hundreds, thousands of other questions. So now we just, because by the way, we just got mentioned by New York Times last week. So they actually cited this particular story. They mentioned that right now, 99.5% of prospect students got automatically answered already. But remember, we didn't do anything about it, seriously. So just people who are the recruitment specialists in that office did that, right? So they feel like empowered. So that's what I'm also very, enthusiastic about it. So it's about this, going back to what Dakuo said, it's a collaborator. But of course, there are different types of collaborator, but definitely machines are not the peer collaborators. They are kind of assistants, right? So they need supervisors. The most important things when we talk about it is, if you're thinking about it, there's a supervisor-assistant relationship, you cannot abandon your assistant. You have to go check in. You have to continuously teach, continuously improve your assistant. So it's very similar to what in a real world, right? Apprenticeship. So I'm going to stop there. So just basically a collaborator and assistant.
Okay. So when I saw this question, I also thought that AI should be a kind of a collaborator or assistant of human. And then I started to think, so what kind of assist do we want? And by looking at recent situation in the world, and I also, in my university, I'm also working on divergence. I don't know how I can say that in English. Female researchers or female professors are really, a number of female professors are really low in our university. So I'm in the position to encourage more, invite more female researchers or professors in this university. So divergence is
diversity.
Yeah,
Diversity.
Thank you very much. Diversity is very important, but we have unconscious bias or that kind of bias or cultural difference. Those things not avoid. Make it hard for us to realize that kind of diversity. So I want AI to be make us aware of that kind of unconscious bias or diversity or cultural difference. I want that kind of assist to human. So that's one example. Yeah.
Yeah.
Yep.
Okay, so thank you for your answers. I think, yeah, we talked about this. It looks like all of you are agree with this, that the AI system should be a system for the human to augment the human's ability, even empower the human's feeling of being empowered, right? So, okay, so our second question is, what design process works best for creating AI or creating a robot that collaborate with humans? So how did this process deploy in your product? So we directly this question directly to Michelle, and if Dakuo or Hideaki want to answer this question, then we can also discuss on these questions. Yeah, Michelle, please.
Yeah, thank you, Yi-Chieh. So as I mentioned in my little slide, right, one slide, I mentioned that again, I'm going back to this supervisor-assistant relationship. And by the way, actually, I'm not sure you have read this in audience as well. You have read there's an article about the DARPA's Super Bowl of robots, right? So again, they also figured out that the winning teams always has this great balance of supervisor-assistant relationship. So if it's a real supervisor, they let the assistant that could do what they do. But if it's the overbearing, you basically over teaching them and they always fail. But if you under teach them, it always fail too. So there has to be strike this balance of a supervisor assistant relationship. Because of this one, we have been conscientiously actually to guide the process, right? So one, as I mentioned, it is, so think about it. If you have a human assistant, right? You would not to teach this assistant every single little details, but you want to stay at a high level, right? So as I gave an example, I'm going to use Professor Hideaki, right? Hideaki? Yes, example about this bias one. So actually currently some other companies are using our AI to do interviews. So in this interview process, they want the AI to ask questions like, for example, what is the worst experience you have ever had at work? Or what is your best experience at the one? Can think about it is this open-ended questions the users, the interviewees in this case, would probably come up with a very diverse, complex answers, right? But you don't want the interviewers, in this case, the human hiring manager, to think about all the possibilities. So the human actually recruiter, human hiring manager just tell the AI, you go ahead to ask these questions, right? So as how they're going to handle the interviewees, we call it digrations, which means the interviewee might say is, I don't want to answer this question. I don't have any good answer to you, right? So you can think about how you should handle this kind of a situation. And also if the human interviewees come here to say, oh my God, and why you're asking this question, right? So in this case, it is the AI assistants should be automatically handle those what we call the exceptions, fallbacks, side talkings automatically. It shouldn't be worried about by your supervisor, right? So that's one, stay at a high level. So second part, as I also mentioned earlier, the supervisors cannot abandon your assistants. If you abandon your assistant, your users are definitely going to abandon your assistant as well. So in this case, we have actually, every time when we do tutorial everything, we have to be very kind of, carefully stress to our human supervisors. Remember, you have to check in on your assistants all the time, right? Maybe at the beginning, especially like kind of you hire a new hire, right? You will check in a little bit more like on a daily basis. But as time goes on, your assistant has learned so much knowledge already, then you don't need to check in on every day. You can check in maybe every week, every month. Like the UI example I said that before they check in every single day. Now they check in maybe 5 minutes every week. So basically, again, so from the AI systems point of view, you have to support those, what do we call the progressive incremental teaching, learning. But from a human's point of view, it is they need to pay attention to their assistant, right? To see what's not working and what's not, and also consider get all the feedback. Remember, like in our workplace, and if I'm a manager, I have an employee, I always say, hey, I want to know how your co-workers talk about you, right? So in this case, it is from a AI assistant point of view, you should also enable your AI assistant to elicit feedback from users as well, explicit feedback. So then you can use this to teach, improve your AI assistant. So I don't see there's much of the difference between the human relationship as a human assistant relationship versus the human machine relationship, because just stay at a high level and also but checking in on your AI assistant and teach and improve it as time goes on continuously. I would say continuously. Okay. Yeah.
So Dakuo or Hideaki, do you like to answer this question too?
Not very much, but I think that we need a way to train AI in a human in the loop way. So eventually, just Michelle said. So to do that, it is very important for AI to show what the AI is thinking or how the AI make this kind of suggestion, something like that. So I think we need some kind of I don't know if it's a social cue or something else, but we need some kind of cues for us to understand what AI is thinking.
Yeah. Thank you. So Dakuo, I think it's also echo your work about transparency, right? So
yeah, I totally agree with the other two panelists' opinion, right? So I think, they also hinted, right? So they also hinted that, it's very easy to design a bad AI that cannot let the user understand what it is doing, right? But if you think about human-human collaboration, right? It's also very easy to have a bad human collaborator that you don't know what the other human collaborator is doing, right? We as HCI or CSCW researchers, we have years or decades of theory and practice of understanding how to design technology to support better human-human collaboration, right? Things like boundary objects, things like collaboration awareness, right? These theories, these empirical findings can again be used in our design of AI system. I think that's something that we have as a community, we have a unique opportunity here, right? So we understand how human works, and we should be the best researchers to design how human AI collaboration work. Thank you.
Yeah, thank you, Dakuo.
Thank you. I'd like to ask that this was really interesting discussion, and so I'd like to ask a follow-up question, and that which is also related to my next question. The bias and the transparency issues. That's the discussion the panelist mentioned. I'm still wondering how would you, so Hideaki was saying that hope AI can help with our bias, but there's actually a lot of contentions around AI systems that it embeds bias or in the algorithm. So I wonder, for your perspective, three of your perspectives, how do we actually try to minimize or make it more transparent to what's going on in the algorithm? This is my own curiosity, and which may lead to the next question. What is the big good or bad AI system? What are the examples of them? Thank you.
I can take this question out because we do have a ongoing submission to NACO this year. Is talking about NLP's bias. So the work, very quickly summarize the work, what we did, right? So we look at some very common fairy tale storybooks that we crawled from Gutenberg. So these are all publicly available classic storybooks, fairy tale storybooks, like Cinderella, like the Snow White and Seven Dwarfs, like Alibaba and the 40 Thieves, right? The globally popular books, right? And then we figure, we all know that there are various social stereotypes exist in these kind of books. For example, if you mention stepmother, right, very likely is an evil character. If you mention princess, very likely the princess is weak and being captured or caged in a castle, eating a poisoned apple and died, or waiting a prince to come to save her. Right, so this kind of portraiting of a male character being so brave and adventure, right, like adventure, and the female character being so weak and being wait the male character to save her, it is some kind of social stereotype or bias we quantify, right? So our work is just to design a toolkit, automatic toolkit to automatically detect if story or narrative document has such a bias. And then if so, then how can we mitigate the model? Any machine learning model, for example, the model may be used to answer a question, or the model may be used to summarize the story, right? So any of these models, right? We can have a way to help mitigate bias may exist in this model, right? So that's the work. To answer your question, I think, machine learning, or at least this kind of learning-based neural network models, so they're merely capturing the data distribution or the features that exist in the existing data set, right? It's not because model want to be biased or the AI researcher want the model to be biased. It's our human society has so much biased data set, right? From history, right? From old days. So I think that's something, but we now know that it's a particular issue, right? So if you don't deal with it, then the AI chatbot, for example, we build using this data set will always tell 7 years old girl to be relaxing and waiting to be saved by another one. That's really bad impression you would want to have on this generation, right? This generation of kids. So we definitely need to deal with that. But I think these are particular. This is a ever evolving kind of topic, right? We are paying the debt that our previous generations have embedded into the society. I think we're making very good progress, but I don't see how we can solve it, like let's say in the next 5 years, or there's a silver lining solution. I think it deserves all of us to spend our effort to tackle on it, and raising awareness is definitely something very good, and then also spend effort to incorporate these considerations, or fighting against the bias, fighting against the social stereotyping, or fighting for diversity, right, equity, I think in our day-to-day research work. I think that would be a very good way to go.
Thank you so much, Dakuo. That was great. I wonder if Hideaki or Michelle has a take on this. That's okay. And my follow-up question for the related to the previous one. So the good and bad examples of AI system, and how would you define their success or failure? Since you touched that in your presentation, Dakuo, could you please also answer it? Thank you.
Yes, so I'll be quick, right? So in my presentation, I did mention that the evaluation, right? So once we build the system, we should always evaluate against the target user. And when we build the system, we should probably, it would be a nice idea to always start with studying the user, right? That's the very basic user-centered design, UCD research methodology, right? That's proposed by Don Norman in 1970s, and it's still valid, right, in designing these AI systems. So if our AI system satisfy the particular user needs and the challenge that we identified from our user study, I would say, that's a good AI system. Right, and of course there are various thinkings and considerations we need to make sure that the AI system is not causing any unexpected consequences. So one example is that it's very funny. I think it's very funny, but a fascinating research project. Right, last year we were all talking about the AI trust. Right, how can you design the AI system to make people trust it if the AI has a very good performance? Right, how can you have a human to trust AI in a particular decision-making process? For example, like as simple as annotating an image, AI can give you a suggestion. You also listen to that AI suggestion, and then you make a decision. Right. Last year we were talking about how can you build a trust. This year, very recently, you will see more and more research work talking about over-trusting AI, which is caused because now humans know that the AI system has a very good performance, but then they stopped thinking, right? They say, oh, there's a very ambiguous case, right? I'm not sure, but the AI tell me it's true. Okay, so I'll listen to AI. So over-trust, right, over-reliance is a real problem nowadays. So when you look at the human AI decision-making, together decision-making, the upper bound is actually the AI performance. It's not really delivering what we hope that they deliver, right? When AI is wrong, human can jump in. So you see, these are the things that I think we'll see more and more these emerging new topics when we have more and more AI applications deployed into the. But the fundamental, I think that a basic AI ethical AI system should be the one that can provide benefit to user, right? So I think that's the bottom line of ethical AI system.
Okay, yeah. Thank you for your response for this question. So our next question is want to directly to Hideaki, and it's about what aspect of the human collaborations could be used as a models for human robot or human AI collaboration, and how this aspect inform your prior works.
So I have worked with social scientists for more than 20 years, and I learned a lot from social science. For example, how we move our body when we communicate with people, and for how we talk when we communicate with people, and strategies to in a conversation. And one example is restart and pauses. And if we are aware that the hearer is not paying attention to me, I suddenly stop saying something like this. Then other people think something happened, and then look at me. And in that way, we can get attention of other people. And so I implemented that strategy to a robot. And if a robot detects the listener, for example, especially in the museum, when the visitor is not paying attention to the robot's explanation about the exhibits, then robots suddenly stop saying something. And then the visitor look at the robot, and when robot detects that the visitor looks at the robot again, then it starts saying, explanation again. So that kind of things. Or another example is F formation and body talk. When we talk with someone else, we not only orient our gaze to that person, but we also orient our body to that person. And if my body is orienting toward this direction, but just head is orienting toward this direction, my main interest is in front of my body orientation. But the head orientation, if my body and head is twisted, the head orientation only shows that temporal interest to that direction. So that informed me how we can design a robot and how we can design the robot's movement. So based on that kind of implication, I made the robot. We developed a robot that can twist its body nicely. So that kind of social science or maybe psychology can inform us how we can design robots, and maybe how that kind of insights also tell us how we can develop really good AI to show to show the intention of the system machine. Mm-hmm. And one drawback of my approach was that the robot or maybe avatar in the VR can achieve the level of human because I'm learning from human. But very old a paper titled Beyond Being There tells us it is better not to learn from human, but we'd better think of something different, design the system that makes us more than human. So that's very important insight. And so I'm trying to come up with a new idea that go beyond human, but it is not easy. So that's my challenge, and maybe other researchers' challenges there, how we can go beyond human. But yeah, that's my answer.
Yeah.
Good question.
Thank you. So I have a follow-up question here. I think like in your work, you say you collaborate with social scientists or know some theories from psychology. And also in Michelle's work, Michelle also have the active listening in your system, right? So I wonder, like, how did you make the decisions, like what kind of theory or what kind of psychology, behavior science things you want to adapt to your system? Like how did you make this kind of decision? Which one is a good one for the AI? Yeah.
So in my experience, I regularly had meetings with social scientists and do the analysis together. And my kind of one of the worst experience was that because as an engineer, when I develop a system, I want to say that this system is good. But when I worked with social scientists, he found the problem of the system, and he wrote a paper that tells this system has this kind of problem. And at the beginning, I thought it's really kind of shocking to me, and I didn't feel good about that. But eventually, as I discussed with the social scientists, I eventually came up with the idea to improve the system. So by constant discussion with those people and let them find problems, it becomes clearer what I should improve or what aspect I can use or something like that. So this continuous collaboration is, I think, very important.
Okay, so Michelle, do you have any response for this question? Because you also like have use the active listening in your system, right? So how did you make this decision? Why you want to have active listening instead of other features? Yeah.
So I think for active listening one, it is because you want the human AI interactions most productive, right? So this is like human to human communication. Active listening is one of the skills we're trying to use to make human to human interaction more productive, more effective, right? So like Hideaki said earlier, he is maybe collaborating with the social scientists, right? So actually I want to kind of bring in another angle, which is very interesting now. So right now, as we said earlier, now the humans can train AI with no code, right? Which means anybody can do that. But not everybody is great communicator, right? Not everybody, like Hideaki said earlier, maybe they shouldn't just learn from humans directly. So the issue here is one challenge for us too. So we're trying to actually give seminars, give kind of like courses to say, how can you also teach the human supervisors to be a great communicators? Because whatever they teach their assistants is to reflect their communication styles, right? So we said, oh, you should anticipate your users' questions. You should be empathetic. So that's kind of interesting spin on this one, because now it's what do we call the democratization of AI, right? If democratizing AI, then everybody can be AI, like Dakuo said earlier, like a TAI just kind of unselectively choosing to learn from something. But you can think about right now, if everybody can do that, and then there is going to be an issue, right? So how they're going to have the skills to teach their assistants to be very effective, to be very empathetic, to be very responsible. So I don't know about the answer yet, but just the discussions I heard, and it's really, I think about that's another challenge, right? So how can you also train humans to be a better supervisor? It's kind of not everybody is a good manager, right? Not everybody is a good supervisor. So how did you train that? That's kind of interesting thing to yeah. And also we often talk about this one because we sometimes will compare our work. It's as easy as to use PowerPoint. I just realized that not everybody is a very good PowerPoint maker. So I just it's interesting. Yeah, I think this is one of the challenges. I would love to hear what other people are doing right now to train the humans to be a better collaborators, to be a better actually supervisors.
So Dakuo, do you like to say something?
Yeah, I have a very nice chart, to talk about this human AI. So for AI, right? So it's definitely modeling beyond human, right? So we don't want to build, in many cases, we don't want to build AI to like human. We want to build the AI to beyond, to go beyond human, because that's the right way to have the collaboration. So let me share you this very nice photo. I think you will like it, this story. So this is a story told by Tom Erickson, my friend and colleague. So he always uses this nice example to explain what a partnership is. Human, dog, and the sheep, right? So in this chart, right, human has a plan, right? So this is our user. So human is our user, right? Human has a plan. I need the sheep go over there, right, for sharing, okay? And then human's assistant, right? This could be the model for our AI system. If we are building an AI system to support human, it's the dog, right? So the dog is, is a predator with a instinct, but the useful sensing, right, and tropism, right? So the dog. So if you understand how these shepherd dogs are raised, they're actually raised together with sheep, so that they consider sheep like mom. Okay, they are about to bolt. I wish I could kill them, but they look really like mom. So that's how the dog think, right? And then what the sheep, right? So they say, oh, watch out! Is that creepy? Keep a distance from it, right? So together they form this ecosystem. We're not building, agent or partner like to use natural language. No, but in this scenario, right, this dog model is maybe a right model that we want to build AI if we are building AI, right? So that, I think that can help us to expand our perspective a little bit to think about this what we are really building when we talk about human AI collaboration.
I love it, Dakuo. It's really cool. And also, I just want to add to that too. It's also very interesting. Yesterday, because of our maybe the New York Times coverage, we got so many questions come in. One asked the question very interesting. It said it's talking to AI, right? Not human.
Yeah.
But it is. Do you think you will be better than human and to handle hostile users? Hostility. And actually, so the AI said it is. So in our case, we have some kind of like a pre-authored one.
Right.
So the AI said it is. Yeah, maybe I am better than human because those hurtful words don't really hurt me, right? So true, right? Yeah. So in this case, it is. I think what Dakuo showed this one. I like it really analogy with a dog, right? Dog doesn't have the things like a human has, right? Maybe dog is much less feel tired running around too. It's the same thing here. So the machines really can do something human can't. So if you say bad things to the AI doesn't feel anything, right? But you say bad things to humans very hurt. Maybe they're going to be on strike. I'm not going to work anymore because it's a nasty customer, right? Yeah. But your AI would not do that. So the reason I just saw this one was very kind of like triggered me. My another thought it is, maybe it's better to handle hostility than humans to handle. Because humans has these emotional burdens, right? Yes. Doesn't matter, even not toward you. I still feel it. You say I'm very bad. You say I'm very incompetent. Hey, doesn't matter what. I feel unhappy, right? Yeah. But the AI, hey.
No, I totally agree, Michelle. I think you are spotting onto something, right? So if you read the paper from last year and this year's CSCW and Kai, right? There's a very recent hot topic, which is the mental health for content moderators. For
it's crazy,
right? So if you have one human read, even they are just trying to filter them out, right? So but when they do this work day and night, right, and then their emotion, right, their mental health are definitely influenced by that. But if you have an AI to do the first layer of screening or helping, right, so then I think it can significantly help with this mental health issue with online moderators. So I think there may be a great opportunity there.
Yep, I agree.
Yeah. So thank you for your response. I think it's really good discussions. Then we learn a lot from here. So I think for now we open the questions from the audience. Then we can have further discussion here. So please feel free to ask any questions, and also unmute yourself. Then we can have chat together. From like anyone. Or Hao-Chuan, do you want to launch the first?
Hello, everyone. This is Hao-Chuan. So I feel I should jump in a little bit, just to, it's a really great opportunity to have this panel. And I just want to give our panelists a little bit background of this, because this event was mainly hosted by TAICHI, okay, which is the Taiwanese Association for Computer-Human Interaction, okay, which is also a CSCW local chapter. And we've been doing this for about, is that a year? I think we've been having a series of online panels for quite some time. And I started the idea, and then I discussed with our president, okay, President Zhou, okay, I don't think he's here. And then we started the CSCW session. For the first one is TAICHI Cross CSCW, and then they expand that to WIST, IUI, and some other things, and then I think that, well, maybe we should come back to CSCW again. And then when we brainstorm about the topic, what to talk about for CSCW, it just comes to my mind that we should talk about AI. And because in CSCW, we've been talking about this all the time, but for the TAICHI audience, I think this is the first time we talk about this, okay? And so I think we should be talking about it. And so it's a great panel. I've been learning a lot, but I guess there's still one question. And every time when we review paper or when we write a paper, we struggle with this question. How should we describe that? Should we say this is human AI interaction? Should we say this is human AI collaboration? Should we say this is AI augmented, some kind of a tool or systems? So sometimes it feels that we have a principle, but a lot of time it also made me feel like it's just ad hoc. You sort of pick a term that you feel right at that moment. But when we say collaboration, what do we actually mean by collaboration? Actually, I know it's quite broad. Even in CSCW, we see collaboration very diversely. Okay, but fundamentally, I think people will still see that there's some collaborative process that we are looking at. And so I just wonder if we just don't think about human and AI, we just focus on the word collaboration. Do you think that this word has any kind of unique meaning that we should preserve that, or we just use this in an ad hoc manner? Pretty long question and pretty long context. Yeah. But collaboration, what do you think about collaboration? Is that the right word we are using here?
Yeah. If we say, if we want to use the term collaboration, maybe the AI should be able to read or understand our intention, then flexibly change its action by understanding our intention or predicting our what we are human is going to do. So we need to say collaboration. I think we need more really intelligent AI. And at the moment, I think it is, the current AI is still interaction. So just interact how the AI should present or how its user interface should be. If the focus of the study is a kind of interface, then maybe we should say interaction. But if the focus is more intelligent AI, I mean, AI is intelligent, but that can read human, then we can start saying collaboration. That's my idea.
Okay.
So
so because when we think about CSW, the name, right, of CSW, the computer supported cooperative work, right, and later we add the social computing at the end of CSW, right? So then I always consider this collaboration as a very broad definition, right? So the dictionary say, like, it's the action that more than one people jointly act on something to produce or create something, right? So that's the definition. But if that's why our CSW committee always appreciate the work from even computer games, right? Multi-user computer games or online community, right? All these things are considered as collaboration. So in this case, I prefer to use the collaboration term or human AI collaboration term because I want to emphasize or even differentiate our philosophy from the performance-driven AI work, right? So I want to emphasize that we should focus on the process that the human and AI can act together, jointly have this action. So that's the process, as well as the outcome, right? So together they should be able to produce something or create something at a better quality. So process and outcome is the main focus of my research work, and that's why I maybe it's a little bit inaccurate to use human AI collaboration, but I prefer to use that term to raise people's awareness here. That's just my personal preference.
I think I agree with Dakuo in some way. And also collaboration also, as I said, even though AI, machine, and humans are not equal collaborators, right? But they are collaborating in a way. So like actually in some of our uses, I would say it's a true collaboration, right? So for example, like the AI coach assistant. So before human coaches would actually deliver the coaching session, and the AI could really serve as assistant and then helping the coach gather initial information and then understand who are when I say coaches, in the students, right? Student coaching or maybe employee and career coaching. So in this case, they collaborate, right? Almost like if Dakuo and I collaborating, I would say, Dakuo said, hey, Michelle, you can go ahead to get some information from the users first. I will go get there. And then I present that information to Dakuo, say, hey, now you do next. So it's, I think in this kind of system, they work in tandem, I would say, right? So they are collaboration, but maybe not be like a peer collaborating like normally we see, but also they cooperative, right? Cooperative, when I think about the word cooperative, it is if you ask AI to do whatever you want to do, they will do whatever you want them to do. So I would say that's cooperative too. Yeah. So in my vocabulary, yes, collaboration is very broad, broad meaning, right? And
yeah.
Mhm.
Yeah, I was recently thinking that, so, and maybe that's just my piece of thoughts, I was thinking that, perhaps there are two words in CSCW. I think one word is maybe the kind of work that we've been seeing, for many, many years. And maybe at some time, we start to form some theories, and then perhaps we can call it theoretical CSCW. And I'm thinking that we are having a kind of work called applied CSCW. And applied CSCW, I see, it's just my personal wording and the definition. I think it's about applying what we know from human collaboration to maybe human AI and some other kind of collaboration. But it's just my recent thoughts. I've been talking with student and collaborators, but then I appreciate a lot of inputs from you. I think we share some thoughts here.
Yeah. So thank you for Hao-Chuan's introduction for TAICHI and also for your questions. So any questions from audience? I think I received. Yeah.
There's a question, Yi-Chieh, in the chat.
Yeah, there's a
Xiao Weiling.
Do you like to unmute yourself and talk about
No,
your
it's in the
questions?
chat. It's in the chat. Maybe we can try to read it out.
Okay.
When designing an AI system, we tend to make it more human-like in several ways, such as social cues and natural language. But at the same time, as Dakuo has mentioned, we still have to prevent potential risks caused by overtrust. In order to prevent overtrust, what information should AI provide? How can we maintain a balance between making people trust and preventing them from overtrusting?
Yeah. Oh, that's a great question. I'll just take that. That's a great question. And that's actually the research question we wrote in 2 ongoing projects, literally that word, right? So balancing the make people trust, but preventing people from overtrust. So it's a very hot topic. If you're interested, I think, we can talk. And also I'm happy to listen to your case studies, which particular scenario are focusing on, right? And then what's the AI system there, and what's the decision, right? What's the human AI collaboration or decision task that there has, right? As long as I know that, I have collaborators or friends working from Stanford, from Purdue, from Johns Hopkins. Currently, there are at least 3 different research groups all working on the exactly trying to find the answer for this question, but there's no good answer yet. So it would be a very good research project if you're interested to work on, right, for this year or next year, I would say. Yeah.
Thank you. So maybe read Dakuo's paper for more detail.
No, we don't have a paper yet, so I'm saying this is we don't have. So we want to work. I'm so interested in this answer to this question, but we don't have a paper yet, and I don't think it's a research work or a question can be answered within one particular research project. It's definitely contextual. It's right. It depends on what's the task, what's the user, what's the modality of the AI, right? All these things. So I think we need to have a group of researchers who are interested in this topic, and then we all work together on it. And maybe after a couple of years, we can build a common understanding of what could be a good solution for this. So I really hope that you panelists as well as students listening to this can join effort together. And then I'm looking forward to see more of the work focusing on this.
Somebody wants, somebody wants to offer some comments. I think we should let him to do that.
Sure.
Interesting.
I think that's Yi-Chieh professor from Zhou University. Would you like to make some comments?
Yes, thank you, and thanks for the panelists today. I really appreciate your work and your comments, because I see a really strong trend in bringing technology, bringing our reasoning of computing more and more toward the human perspective or human aspect of the interaction. So I'm going to throw out just a couple of thoughts that's been sort of surrounding the work I've been doing, or the work that my students been doing. First of all, there is a distinction between interaction and collaboration that's being drawn. When in fact, if you look at any sort of interaction, it is collaborative in nature. Because you have to make assumption, about the entity that you're interacting with, and most of the time, even in order to make an interaction fluent, and continual, you have to make assumption about the collaborative nature, that the person's doing something mostly because he's trying to continue to interact with you instead of breaking up the interaction. But however, interaction is also a pretty lonely thing, in that most of the things that you're perceiving about this interaction or collaboration is inferred. And what that means is that what you think the other party is doing may not be true. So it takes a lot to infer on the interactive intention, as the speaker has been mentioning, from the other party. And this is why I generally do kind of start converting from human AI interaction to a different term called human agent interaction. Most of the time, because AI is really not an entity of interaction. AI is a technology, is an enabling capability behind the entity that we're interacting with. And the entity is mostly an agent, whether the agent has a concrete interface or whether the agent looks like a human or not, okay, etc., etc. And therefore, when the entity that we're interacting with itself does not offer any clear rules of engagement, interface usually offers that rules of engagement or information to engage with, but agents sometimes do not. And therefore, we start inferring rules of engagement based on our prior experiences. And that would be many, many kinds of experiences. And this is why that rules of engagement is mostly inferred and estimated by the human perception. And it's not just human perception, it's human social perception, because this is really engaging with another entity. And most entities that we interacted with in the past were human beings. Okay, and this is why a lot of the things we thought we know about human, whether it's his assistant, God knows, teaching assistant is not easy. Human assistants are not necessarily smarter sometimes. And then so therefore, it requires a lot of uncertainty inferences that's involved in this engagement. So the other aspect I think that's been brought up that's very valuable, but however, the field has not made a lot of progresses, in the aspect of control. Because speakers mentioned that this is not a entirely supervisor-supervisee relationship. This relationship can dynamically evolve even within one session of interaction to something that is like totally supervised, to collaborative, to assisting, to help in many different forms. And back in early 2000s, there was a NASA paper about H metaphor. Okay, it's about the H really stands for horse. Now it's to describe the power or the control relationship between the human and the horse when they are moving together. Okay, and so it's very dynamically that the control is being passed from one party to another, depending on the need of the situation. And that is I think that's a metaphor that's really good. But however, I really want to see the field developing more methods and mechanisms to explore how we can dynamically adjust this control or the percentage of control. It's like a spectrum that can be changed on the fly. Okay, and I just this is something that I've been thinking about it myself for some time now. Just to see what social cues or our detection of the capability of the other party, like an agent, okay, can help us adjust that control dynamically, okay, so that we can make the interaction more continual. The other comment, in response to Professor Kuzuoka's comment is that yes, there are many things in social psychology that can probably be helpful in this case. For example, that the experiment that you were describing is a very typical accommodation theory situation where in our engagement with others, whether it's conversational, face-to-face, or many ways, we're trying to orient ourselves toward the other party in both verbal and nonverbal behaviors. So yes, now there have been very elaborative descriptions of these behaviors in a human social psychology literature. So we are also doing similar experiments in our lab, but falls under the umbrella term of accommodation, to see that if the agent can exhibit any sort of accommodating behavior, is that going to facilitate our collaboration with the agent or facilitating our trust in the agent, because we have more indications that this is somebody who has a social capability and then can be sort of more collaborative agents with us. Okay, so in general, I really love the panels that we have today, because I think then I feel very encouraged that these are all good questions that we can all pursue together. Thank you.
Yeah, thank you. So do you have, okay, there's one more questions, right? So I think we can only accept one question now because it's about the time. So the question is from Qing. Do you like to unmute yourself and describe it?
Right. Thanks, Yi-Chieh. Thank you so much for sharing those inspiring opinion and insights about the human-machine collaboration. And I noticed that we talk a lot about the relationship, right, between the human and the machine. The AI. But I was also very curious about the collaboration failure. So in a human-human collaboration, it's very normal to have this failure, and people can try to coordinate and resolve this failure, right? And I was wondering, like in your real research scenario, do you have some insight of how this failure between a human and machine, the AI failure happened, and how the collaboration scheme that you use to resolve and something like that for those insights? Thanks.
Well, I will just take a step on this, right? So, as I mentioned or hinted in my presentation, right? I think one reason for the failure could be, it's 11:30. The AI is designed trying to show off itself, right? Or the designer, the engineer builds the AI to show off itself to the user. Say like, oh, I can read this CT scan better than a radiologist, human radiologist. And then, apparently many humans do not like such a collaborator. And then together with many other cases, right? So many other reasons like, integration with the context, integration with the existing ID system, all these things. And then it could cause a failure. So we have observed so many of these cases, right? So what would happen? Maybe the user would, just abandon the system. So that's the most common ones. And it would be really bad for the company, right? Lots of layoffs, for example, right? So IBM has lots of layoff and we decided not to touch any healthcare related things because of these. Right? It's much more complicated than the people or the decision maker were imagining 3 or 4 years ago. Right, so now they really finally recognize it's very complicated. We can't have an AI, doctor or AI radiologist to really solve this problem. So yeah, I think this again, right? I have been fascinated with this idea or the question, exactly the question you're asking, right? So I guess many of us are familiar with Johnson Gruden's work, right? Why CSCW system fails, right? I really hope that in the next couple of years, someone, hopefully you can also invite me, but someone can lead this project to write a paper about why AI system fails, right? Why I think that'd be a fascinating and classic paper to read, right?
Dakuo, are you saying that we have a conclusion already?
But at least we can summarize, right? We can summarize what we observed. That's what Johnson did, right? So Johnson did from observation, literature review of various empirical projects, right? Why CSCW system fails, right? And I don't think we can, summarize all the factors, all the causes, but at least we can identify some common ones, right? Like what Johnson did, right? So if you are asking the user who pay the price not enjoying the benefit, right? The system could very likely fail, right? Things like this, I think would be very insightful for today's practitioners to read.
I think a lot of failures of AI or human-robot interaction comes from the misunderstanding about the capability of the robot or AI. So I don't have a good answer, but all the stakeholders who trying to apply AI or a robot understand the capability of the robot or human. or AI. That's very important. If someone misunderstand or overestimate, the whole kind of system fails. So yeah, that's my thought. Thank you.
Thank you.
And I think another thing is this is unmatched expectations between humans and AI intelligence, right? So like our head of sales always said this is a trough of disillusionment. So what happened here is people who are building AI systems tend to overpromise. Tells you, oh, we can do this one, can do that one, but actually they can't, right? So once humans are super smart. Once they go there, try it, they felt like, hey, it didn't really do what I expected, and not just that, and it's worse than I expected. Then it's not going to go very far, right? And also humans also judge it by the human standards. So I remember, I think I came from IBM as well. And in a way it is, if you guys still remember the voice recognition, right? So even voice recognition, if people improve the system from 80% to 90%, that's still not sufficient for humans, because humans want to 99.9, maybe 100%, right? So I think it's very important. It is to find the right AI applications is very, very important. And basically to be very transparent on what AI can do, cannot do. And so this one, you meet humans' expectation. But I think as long as the humans are notified, are aware of what they can expect, I think humans are pretty reasonable. So they will actually try very hard to collaborate with the machines because they think machines help them, right? So I think this one, so I think another good example for this one, it is, IBM speech groups is extremely smart, I thought. So then they couldn't do the voice record, but they can apply the voice record to translation system. So once you apply the translation system, if you don't have a translation, that's 0. But if you have some translation, even if you have 80%, even 20%, it's still 0 to 20% beats are nothing, right? So people's expectation completely changed. So let's think about the soldiers used to be in Iraq or somewhere. So if they don't understand at all, then it will be 0, right? They could get killed. But hey, if you have some translation going on, if not 100%, it's 20%. Hey, 20%, it beats are nothing. Maybe save lives too. So that's why it's a kind of how you going to set up expectations for the users and how you actually, not just a set of expectations, how you actually inform the users what AI can do and cannot do. I think it's very, very important. Like one of the things we have been doing is we call it automatically generating a help menu, right? We often forget it. We often just say, oh, just tell them what, especially in these days, AI technology is advancing very fast, but still it's far away from being perfect. So I think having that level of transparency is very important, because it's not just being humble, actually the set of expectations most important. And one of the psychologists used to say this one, when you set up expectations, people tend to go away with it. When one experiments it is, if you see people have a long line, right? If you cut into a line, people hate you. But if you say, excuse me, I really have, people don't care what you said. But as soon as you say, excuse me, they'll give you the leeway, they'll let you cut line. But if you don't say anything, hey, it means you don't give any expectations.
Yeah, so I think, to answer Hao-Chuan's question, right, at least we now have 2 possible reasons. One is mismatch of expectation. The other one is, building AI to replace people, right? So I'm sure that these are the factors I definitely observe, right? So is this mismatch of expectations one major reason why my AI system failed?
Right, but people change a lot too, right? So people, when they use more technologies, they know more and more, right? Yep. And I think it's going to be really interesting. CSCW system might be failing in the past, but it's still pretty strong. And actually, I think we use all the CSCW system like room chat every day, right? Yeah. So it saved the world in some way, right?
So transparency is very important, right? So even in human-to-human collaboration, human-to-human communication is also very important. If you don't tell your collaborators what do you do, what you can do, cannot do, and your collaborators are bound to be very disappointed.
Yes.
Right? That's why, so it's part transparency, and because the transparency, it's not just the set of expectations, it's actually being much more actually, how do you say, informative, right?
Yeah, I totally agree. But I just think that
responsible.
I totally agree. I just one quick comment, right? I feel that a lot of time it doesn't have to be in the design time, because when people use the system and it broke, people learn from it. And the point is like people have to try again, because if they try again, they change the way they use it, they will benefit, right? And that's what we see a lot of times in translation system. There was a period of time people don't trust machine translation, right? But then when people know that there's just this limit, right? And I think people in general are happy with that right now. People start to benefit from it. So just my observation. I think time and also just let user to learn, and then the system will train user too, right? So if we say training, just quick thoughts,
Yep.
And the way people look at technology will change over time, because when any technology first come out, there's bound to be some people worry about their job being replaced. When spreadsheet, Excel, VCAL first came out, all the accountants thought that they're getting out of a job. So it really depends on how people later come to perceive the role of the technology. And finally kind of put them into the right place. So at the beginning, the misunderstandings or wrong expectations are almost inevitable. And frankly, I don't really worry about that. It's really that once we see more and more applications. The other thing about transparencies is this: most of the time, we don't have the transparency even among the very basic things that we interact with. We have a mental model that works. That's all we have. When we use smartphone, you don't have transparency about the smartphone, but you have a mental model of how this thing works. A lot of the time, when AI are being put into an agency or an applications, I think it's the same. You have to know something about this so that you can come to the right expectation of what they can do. So revealing the internal mechanism does help, to some extent, that it helps you form that mental model. But beyond that may not be necessary.
Okay, so thank you for this fruitful discussion, and I think our time is up. So we are going to wrap up this chat session. So Ying-Yu, do you like to say something before we end up this meeting?
No, but thank you so much for your great discussion. And we hope that this is a starting point, like Dakuo said, in the other discussants or participants, that this is a beginning for us to talk about important questions and form collaboration and keep pursuing on this newly like more emergent topic in CSCW. And thank you all, and we hope we have more, and especially thanks to our discussant panelists. Thank you.
Yeah, thank you. Thank you so much to join our discussion today. Yeah.
Thank you.
Thank you.
Thank you so much for inviting us.
Bye. Yeah.
Thanks.
Bye.